The path of sperm. So if we kind of review what we've talked about so far and a sneak preview of what's coming up, a testis or a testicle is where they're made and where they begin. They end up in the epididymis. So I'm going to highlight some of these for you. The epididymis, right here. And then from the epididymis, they're going to end up in the vas deferens. I'm actually going to use yellow for this. This is also called the ductus deferens. Here, they use the word vas deferens. I tend to use vas deferens instead of ductus deferens because the term vasectomy, which you're going to hear more about later in the lesson, is when surgically the vas deferens is clipped. But here's the vas deferens in yellow. Actually, that yellow is hard to see. Let's do it in green. So here it is. It goes out of the scrotal sac, inside the abdomen, all the way to here. And then you're going to get little accessory glands on the way to the urethra. So keep in mind that this is the bladder. Here's the urethra. And you're actually going to get the vas deferens or ductus deferens going all the way to here. And then once it comes into contact with the urethra, that's effectively the end of it. But associated with that ductus deferens or vas deferens, you've got several accessory glands. So first, the seminal vesicles. Seminal vesicles. Here's the first kind of gland that is a major contributor to semen. So the seminal vesicle adds some fluid to that passageway. The prostate gland also is going to add some fluid. So the prostate gland is actually surrounding the urethra. You can see it's just inferior to the bladder. The ductus deferens goes through it, and then it adds some fluids to form more of semen. The prostate gland is kind of has the look of a chestnut. And then in purple is the bulbourethral glands, also called Cowper's glands. You can see right here. There actually are two near the base of the penis, and you can see that they're that last little set of contributors to what's going to end up in the urethra and coming out of the penis during sexual stimulation or intercourse. And then the urethra, yeah, that is the last passageway. Urine also goes out through it, but during sexual intercourse, urine's not going to be going out. It's going to be semen. So the vas deferens, also called ductus deferens, each one is about 40 to 45 centimeters long. It takes sperm from the epididymides, that's plural for epididymis, so the epididymides to the ejaculatory duct, which is right next to where the urethra is and kind of where it meets with the vas deferens portion. It runs adjacent to the bladder. We saw that in the previous slide, and passes by accessory glands, the seminal vesicles, the prostate gland, and the Cowper's gland. And in the vas deferens, you can see a thick layer of smooth muscles in the walls. That's what actually gets sperm out of the testes, all the way through this tract, and to receive those additional secretions from the glands. So peristalsis, we've seen this term come up a lot. It's those wave-like muscular contractions in the tube that encourages the movement of the sperm. And amazingly, the vas deferens can store sperm in it for several months. So it's more typical, of course, for sperm to be stored in the epididymis. But they can gradually creep up into the vas deferens. And that's why even after a vasectomy, when you cut the connection that takes sperm from the testes through that tube to meet eventually with the urethra, you can still have a chance of impregnating a woman because even though you've prevented sperm from leaving the testes, you can have some sperm remaining in the vas deferens. So the doctor will tell you to wait a while before having unprotected sex. And I've heard stories of even like months after, even a year after having a vasectomy, it's possible to get a female pregnant. It's rare because the amount of sperm that are going to be hanging out in the vas deferens is a lot less than the amount that's released through the average ejaculation. But hey, all it takes is one sperm. Seminal vesicles. These are also called seminal glands. They're between the posterior part of the bladder and the rectum. They contribute about 60% of semen volume. So most of semen volume is thanks to the seminal vesicles. So you can see here's the vas deferens, and remember it goes through the prostate. Here's the urethra. So the prostate is the area where you're actually going to see the urethra and vas deferens connecting. The seminal vesicle right here is what's going to be actually contributing these items. So first, fructose. That's a sugar, and fructose is added to the mixture, which includes mostly sperm at this point, because it's like food for their journey. Sperm have those mitochondria. Without being supplied sugars, they're not going to be able to make the ATP that powers their flagella. So fructose is like food for the journey. Prostaglandins actually help create muscular contractions in the male and in the female. Why the female? Well, after having sexual intercourse, it makes it more likely that the sperm are going to get to where they need to go if certain contractions are stimulated in the internal anatomy of the female reproductive system. So prostaglandins are little hormones that help do that. Fibrinogen, we saw that with the bloodstream. And fibrinogen is a chemical that with certain enzymes will be turned into fibrin, which remember can make a blood clot. Why is it here? Well, it will make a semen clot in the female. And it just further improves the chances of fertilizing the female. So fibrinogen will be turned into fibrin inside the female to make a semen clot. And then alkaline secretions. Alkaline means basic rather than acidic. Why alkaline secretions from the seminal vesicles? Because the inside of the female vagina is typically acidic. And that kind of environment could kill sperm. So alkaline secretions help neutralize the acidity inside the vagina and protect the sperm. And actually, the overall pH of semen is slightly